Hello and welcome to NanoReach, a scientific outreach podcast by the Nanomedicine Research Group at the Institute of Chemical Technology, Mumbai. In this episode, I talk to Dr. Prachi Bangde, who is a freshly minted doctoral researcher from NRG. We talk about her PhD research and much more. So let's begin. Hello, Dr. Prachi, and welcome to the NanoReach podcast. I'm super happy to have you here. I was really looking forward to a conversation today.
So, hi, Parth. I'm really excited to start this conversation.
Before we begin, I want to congratulate you on two things particularly. First is defending your PhD thesis, and
Thank you.
which basically means you're done with your PhD. The second thing is congratulations for winning the DST-AWSAR Award on the National Science Day.
Thank you so much. Thank you so much for that.
Dr. Prachi won the AWSAR Award for a very engaging story of her research that she published. You can read the story and get to know more about AWSAR Award by clicking the link in the description. So, was there a moment during your masters or bachelor's when you thought कि हाँ मुझे PhD करना है and मुझे research ही pursue करना है?
Masters में, I started understanding very minute things, how things works, how research works, how fun it is to do research. Like every day is a new thing. It's not like a regular job where you sit and come to your office and just do all the regular monotonous stuff. I always desire to have something new every day.
Right.
So research is one thing where you can actually work on new things every day. You need not like it's not monotonous. So that's
Yes.
the feeling which I get when I do research, and that is what kept me going on, and that is why I pursued PhD right from the same lab as the same guide.
We'll talk about your PhD research. So I
Yeah.
know for a fact that your research is, broadly speaking, it's focused on cancer research, specifically
Yes.
on cancer therapeutics. And
Yes.
now, when we observe in practice, there are two types of therapies. One is general therapy, which includes treatments like chemotherapy and radiation therapy, and other is precision medicine, which involves monoclonal antibodies, for example. So, of these two categories, what was your research more focused in?
My research was focused on, primarily speaking, is that I have to develop some therapy which is very affordable and easy to make. So when you see whenever a cancer patient is getting treated, the first choice of treatment will be chemotherapy, or then surgery or radiation. So all the advanced therapies like immunotherapies or the target or precision medicine which you are saying, those are very good and very efficient, but they are very costly. So that cannot be easily affordable by major of the population, right?
Yes.
So my idea was to develop something very which is very easy and easily available, cheap and available. So I focused on two things out of this, that is chemotherapy and partly like it's like a precision medicine, but it will fall under radiation therapy also.
Okay, so it has components of both the
Yes.
categories.
So components, yeah, the work which I have done, it has components of both
Yes.
categories. Uh, so like if I want to explain, it's like this: key the whole PhD work I focused on palladium metal. So palladium metal I've used in a small molecule form, just like small complexes like cisplatin or carboplatinum, and I have also developed palladium based nanoparticles.
Okay.
Okay, so first part was developing small molecules. The prime or the important property of those molecules were that they were highly water soluble.
Okay.
So that the aim to design molecules which are water soluble is because most of the complexes which are present or the chemotherapies which are present today for cancer treatments are actually not water soluble.
Okay.
So what happens is that the formulation,
Mm-hmm.
when people design formulation for such molecules, involves very toxic or organic solvents. And even if this formulation is ready and when ingested by humans or administered in humans, so the bioavailability and efficacy is very reduced due to its poor water soluble or aqueous soluble property. So there is a need to develop molecules which are very good, like having a water soluble property also. And when you know when they are taken up or administered in human, so it can have like increased bioavailability and efficacy.
Okay, got it. So, may I ask one question before you go ahead?
Yeah.
So, why did you choose or why palladium? Like, why not other metals? Like, even gold nanoparticles are used in cancer research. So, but I want to understand why palladium.
So palladium. Firstly, palladium metal that belongs to the same family, which is like palladium family, which includes like palladium, silver, gold, and platinum.
Hmm.
ठीक है
हाँ.
अभी the thing is that कि gold and silver are like really extensively studied for anti-cancer property.
Hmm.
So we wanted to shift focus from those metals and explore metal proper anti-cancer property from a metal which was not that explored.
Okay. Okay.
Was palladium.
Hmm.
So palladium, when you see periodic table, is just present above the platinum metal. So what happened is that the coordination chemistry of palladium is very much similar to platinum. Only the difference is that platinum is in bigger size and palladium is in smaller size, the atom size. I'm
Hmm.
saying.
Hmm.
So now when you see whenever cancer patient is treated, there are like cisplatin based or platinum based chemotherapies which are given.
हाँ.
So prime metal which is used in use or widely used around the world is platinum based uh, chemotherapies. So the idea was to replace this platinum with some other metal which is very similar to platinum yet showing same type of efficacy but not toxicity like platinum.
Okay. Okay. Got it. Hmm.
ठीक है.
Hmm.
So that was the major idea to choose palladium
Palladium.
over other you know elements, that is
हाँ.
silver or even
Gold.
gold.
Hmm.
And then platinum, it shares similar chemistry like platinum, that's why palladium.
Yeah. Got it.
Also I want to add one more thing is that palladium element atom being very small in size compared to platinum, so the toxicity
Mm-hmm.
is like relative, it's predicted to be relatively less, which is shown by platinum based complexes.
Mm-hmm. Okay.
So that is the one thing that another thing rather that was kept in mind while choosing palladium as a metal to study for and as anti-cancer therapies.
Okay. So now you developed these nanoparticles, and how did you employ them to kill cancer cells?
So, as I said, my PhD work was divided into two different parts. First part was developing small molecules, right? So, small molecules were water soluble and stable over a period of very long time. It has that property that it can be formulated in aqueous solution also. So, these complexes were studied against a series of
Okay.
cancer cell lines,
Mhm.
and then we found that it has good uh, killing properties towards breast cancer cell line. So the cytotoxicity was never equal for all types. So we tested for like lung cancer, cervical cancer, then breast cancer.
Mhm.
So out of these three, we found that it is very effective against breast cancer. So we took research forward everything with breast cancer cell lines.
Okay.
So the small molecules were tested, and then we tried to understand how it is actually affecting the biochemical pathway or inducing the apoptosis in breast cancer cell line. And the second part of the work, that is developing palladium nanoparticles. So that is completely different. Here we are trying to replace the radiation therapy. So what happened over here is that
Mhm.
we developed palladium nanoparticles. Now, palladium nanoparticles are widely, studied and explored, already present in literature. The only, beauty and the change that we did is that we tried to make it very biocompatible, because palladium nanoparticle,
Mm-hmm.
just plain form, it is very toxic towards cells, be it cancer or be it
No.
normal.
Okay.
But we wanted to increase biocompatibility, so we coated the palladium nanoparticle with a special, uh, polymer called trimethyl chitosan.
What does the TMC bring to the nanoparticle? Like what advantages? So it increases the solubility or
Yes, yes, yes.
okay.
Actually, it does. So this is one thing.
Mm-hmm.
So actually, this TMC thing came from my master's work. I tried to, design green processes to convert chitosan polymer
Mm-hmm.
into trimethyl chitosan polymer. So chitosan polymer does not have good solubility in neutral or alkaline condition, whereas trimethyl chitosan polymer can dissolve like at a range of pH condition, that is even in acidic, neutral, and alkaline condition. And the mucoadhesion nature, or
Mm-hmm.
the adhesion with the cell membrane, is very good, because cell membranes are normally negative in nature, so this attracts. So when nanoparticles come in contact with cell, it will, easily attract and then, bind towards cells and then get engulfed by the cells essay. That is
Acha.
a basic
So,
thing.
so basically, when you coat these nanoparticles with trimethyl chitosan, this enhances the binding with cancer cells and also makes them, readily take the nanoparticles up.
Yes, yes, right, right.
Okay. Okay. Mhm.
So we form palladium nanoparticle coated with trimethyl chitosan. Then these nanoparticles were actually used as photothermal agents.
So, what do you mean by photothermal agents?
So photothermal, from the name you can say, sees that it involves two elements. That is, photo means light and thermal means temperature,
Hmm.
right? So what happened in this case is that when the nanoparticles are administered, the nanoparticles will specifically get accumulated in the tumor or the disease region. Okay, once the tumor, once the all nanoparticle or maximum of the nanoparticles are accumulated, then
Okay.
externally you have to just, hit it with some specific wavelength light.
Okay.
So once the, nanoparticles are illuminated by this light, the nanoparticles will take up the light energy and convert it into heat energy. So
Oh.
what happens is that this heat will then kill up the cancer cells present in its surrounding. Now, the catch is here that cancer cells are very susceptible to high temperature. So that's why, the heat energy is used to kill cancer cells.
And uh, so consider if these nanoparticles they enter normal cells as well. Okay. But upon radiation, these normal cells won't die.
Major accumulation of nanoparticles will be inside the tumor only. So this is because we are saying, when so there are like too many literature saying that blood vessels are normally leaky in the area of tumor, solid tumor. So what happens is that key nanoparticles will get preferentially, squeezed into this tumor environment or taken up by the tumor cells only, not the by the healthy cells.
Got it.
So
Okay.
that's why you have, nanoparticle as the new thing nowadays. And when compared to normal, chemical based therapies, it has ability to, go into any kind of tissue or organ, or even apart from the, tumor solid tumor region.
Right.
That's why nanoparticle have this property, and the size are so much designed that it will squeeze out from the leaky vessels which is present around the tumor. So this is called enhanced permeation retention effect, EPR effect.
Okay. So that means if you inject these nanoparticles in blood, they will only go to the tumor area because the vessels there are leaky.
Yes, absolutely right.
Okay. 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 Got it. Small molecules be do they reach cancer site or cancer cells via the same mechanism EPR?
No, no. Small molecules are very small molecules. Those are like small chemical molecules.
Okay.
So it has, chances to go around anywhere.
Huh.
Not necessary that it will get accumulated majorly only in tumor, but the only purpose of that molecule is that to increase its water soluble property that will eventually reduce the dose size also.
Okay, got it.
So जब dose size reduce होगा the side effects will reduce. So
Exactly.
if I give you one example, if you see cisplatin or any other carboplatinum or taxils wale complexes, those are molecules which are in which have very big shape, ठीक है? And because of its big shape and size, it is not that easily soluble in water. So whenever this drug molecule is like administered in your body, a major of the drug molecule is washed away from body via excretion. ठीक है? And there
अच्छा.
is very small percentage of the drug which is available,
Yeah,
to
that
treat
get retained in the body.
that get treated in the body and that reaches to your
Okay.
tumor site and then that it shows the effect.
Okay, okay,
This
okay.
बहुत small percentage है.
अच्छा.
ठीक है? So that's why नॉर्मली जब ये कैंसर पेशेंट को केमोथेरेपी देते हैं ना हमेशा ऐसे एग्जैजरेटेड डोज साइज रहता है सो दैट इफ यू हैव लाइक 100 का डोज 100 mg फॉर एग्जांपल आई एम सेइंग तो 100 mg का एटलीस्ट 1 mg जाके इट विल रीच टू ट्यूमर साइट
ओ ओ
आई एम जस्ट सेइंग हाइपोथेटिकल
समझा
सिचुएशन
समझा मैं सो मेजॉरिटी ऑफ इट गेट्स एक्सक्रीटेड
washed away or it gets diverted or gets targeted to some other organ
ऑर्गन
तो बाकी ऑर्गन में अगर ये accumulate हुआ it will show some side effects over there.
ओके
So this is because of not having a good water soluble property. Whereas if some molecule is there which is like very good in water, having water soluble property, the dose size will remain. The dose size will be actually very less in comparison to that which I've given you, like the example. So 100 mg की जगह probably 50 mg will work for me.
समझा
है
समझा
ना? And that 50 mg being very highly bioavailable in your circulating system, it will reach tumor site also,
समझा ओके
like major part of it. I cannot say if it will go only in tumor but also other parts of body, but majorly in the tumor region.
So, just a couple more questions before we go. Huh? So, I wanted to know, like, what are some of your hobbies?
Hobbies, okay. Actually, from childhood, I love, art. So I'm really fan of, colorful things, be it in form of drawings, craft, या painting, या, gardening, वगैरह, कुछ भी हो. It should be colorful. My hobby is everything related to colorful things.
Nice.
So it can be photography, making videos, making some artwork, making some, crafty work, even food. So everything should be colorful. It should have every element of color. I want to, go into more into scientific illustration, but I think somewhere I'm lagging in terms of, communicating science through doodles. So this is the area where I feel I have to like improve or learn more new things because there are already so many existing science communicators and illustrators which are doing amazing job. So there is one person I'm really fond of is Sarjan.
Oh, Ipsazen, yeah, I know it.
Yeah, she is doing really amazing work. Matlab, she has connected art with science.
Yes, I've been following Ipsa's work on Twitter as well. It's very good.
She has done amazing artwork, just so colorful and so mm, relatable to science also in a fun way and artistic way.
Right.
I just love her. I have been following her on Instagram, so I've seen her artwork and all.
Oh, okay.
It's really really amazing, like colorful stuffs and all. That really attracts me. So that is one thing which that's the reason of my like list of hobbies I'm having. Apart from that, I love traveling. So while traveling, I actually love going and knowing in the actual culture of that place. The typical food that you get in that place. वो explore करना is just like I just love that. Then apart from that, I also like to read books also.
Mm-hmm.
But मेरा जो book का I mean like books का जो choice है, it's like more towards mythology. I also wanted to add something. I forgot. Avsar Award का हाँ, the inspiration
हाँ.
which Avsar Award का जो है.
Hmm. हाँ.
So I said earlier, right, कि I have lot of reading.
Mythology.
Yeah,
हाँ.
reading mythology books. Like I was really inspired by Kalki books or the Shiva trilogy by Amish Tripathi. So actually, I picked up those, stories or the characters, not characters, the, asuras and devas from those books.
Mhm.
So I try to relate all the characters' nature or the story narration from those mythology
Stories.
inspired things.
Mhm. Okay, so your research journey, it's so it's evident that you have worked very hard, and it's so inspiring to see your journey. And because of everything that you have achieved, I'm sure it will motivate many others. So, do you have any advice for aspiring scientists?
Just incorporate colors in your work, I would say. So I had this habit during PhD whenever I used to make notes or
Mm-hmm.
write in my lab notebook or my diary, I used to have that habit of using a lot of colors. Notes banana, scribbling karna. I always do it with colorful pens or
Acha.
sketch pens. So with that, you have this psychology when you do things in a different way, the things get more, absorbed in your mind and you actually love doing that also more. So that is one thing I would like to, give advice to everyone if, they can incorporate colors in their work life also. So I would always say कि PhD वाले या कोई भी हो to add or incorporate colors.
Yeah, actually, na, this is written, like even I've read it in a book called Atomic Habits. So, usme, if you want to make a good habit out of something, the trick is to make it attractive. So, I
Yeah,
think
yeah.
your suggestion can be applied here.
Yes, yes. Actually, matlab, it really works for me actually. Actually, I have this habit since my childhood. I was really fascinated with colors since childhood. So whatever things I used to write, question, answers, papers, I used to lot of colors. Notes making bee. Even I remember in 12th standard, I had this chemistry practicals. We never understand what we are doing there. Chemistry में क्या पढ़ रहे हैं, कैसे है ये reactions. We used to just,
Titration.
struggle understanding कि दो chemical mix हुआ, कुछ तो हुआ, organic chemistry हुआ, ये हुआ, वो हुआ. तो one day I got so frustrated, I made a chart. एकदम से क्या बोलते लंबा सा चार्ट बनाया. आई यूज लॉट्स ऑफ कलर, मतलब मैंने एक्सपेरिमेंटली ऐसे सब चीज डिवाइड किया एक ही चार्ट में. ऑल एक्सपेरिमेंट 10 experiments I just wrote it on that. You know what? After that, using colors and making that chart form, मेरे को इतना जल्दी समझ में आ गया, इतना अट्रैक्टिव था ना, मतलब मेरे एक्सपेरिमेंट सब सही निकले. सो आई कुड अंडरस्टैंड कि इसमें क्या हो रहा है, ये क्या रिएक्शन है, ये ऐसा है. मैंने ये अपने फ्रेंड्स को दिखाया.
हाँ.
Friends got so amazed कि मतलब this is really working wonder. Even they were so impressed कि उनको भी समझ में आ गया at one go. The exam के एक दिन पहले they used to ask me, अरे प्राची तेरा चार्ट दिखा मुझे समझने का है. And it was very colorful and in single page.
Wow.
So this actually works.
मैं भी अप्लाई करूंगा अभी. I'll let you know the review कैसे जाएगा ये.
Yes, definitely.
It would be a nice experiment. Dr. Prachi, it was really great talking to you. Thank you for taking out time to do this podcast with me. I wish you all the best for your future. Keep inspiring and keep motivating people. It was so good talking to you. Thank you.
Thank you so much, Bart. Thank you so much.
Thank you for tuning in for the podcast. Hope you all enjoyed it.